For our first approach, we're going to convert the number to a string, push the characters into an array in reverse order, join the characters, and compare it to the string representation of our original number input. This solution has a big O of n time and space complexity. Here we have example 1 with an input of 121. First, we'll set up a base case that returns false if the input is a negative number because a negative number cannot be a palindrome number. Next, we'll initialize a variable called reversed with an empty array as its value. Then we'll convert our number input to a string with the built-in toString method. Now at this point, you could call the built-in string method split, chained with the built-in array reverse method, followed by the built-in array join method, but let's assume you're not allowed to use the reverse method in an interview setting. In this case, we'll iterate in reverse over the string and push the current character to our reversed array. So the iteration will start at the last index, which has a string value of 1, and we'll push it to reversed. The iteration decrements to the next index and pushes it to reversed. Reiterate once more and push the string value of 1 to reversed. Finally, we'll compare our reverse string with our string representation of our original input number. Since we're returning false for negative numbers in our base case, you could safely cast the reverse string back to a number and compare it to the original input, but since we're already converting the original input number to a string and storing it in a variable, it's one less operation we have to perform. Let's translate this to code. Okay, we'll start by setting up our base case. We'll check if the input is a negative number. If it is, we'll return false. Then we'll initialize a variable called reversed with an empty array. Next, we'll convert our input to a string with the toString method. Now we'll set up our for loop. We'll initialize the index to be the last index of our string. We'll check that the index is greater than or equal to 0. And then we will decrement our index once the code block is finished executing. Inside of our for loop, we will push the current character to our reversed array. And then finally, we will return reversed join. We need to join the characters, and we will compare that to our string. And that's our solution. Let's run this against the test cases. And we get the expected output. Let's copy and paste this in a Leetcode. Okay, let's paste it in here. Hit submit. And we get an accepted solution. For our second approach, we're going to utilize math only, and we will not convert the number to a string at any point. This solution has a big O of n time and space complexity. We'll diagram example 1 again with an input of 121. Again, if the input is a negative number, we'll return false. We'll initialize a variable named reverse with 0 as its value, and a variable named copy that will assign the value of our input number. Next, we'll set up a while loop that will iterate as long as copy is greater than 0. The first thing we'll do inside of the while loop is grab the last digit of our number by using the modulo operator with the divisor of 10. Then we will take our current reversed value, multiply it by 10, and add our current digit to it. We'll remove the current digit from our copy by dividing the copy by 10 and passing that quotient to the math floor method. Finally, once our copy is no longer greater than 0 and we exit the while loop, we'll check if reversed is equal to our input number and return the resulting boolean. So 121 modulo 10 gives us a remainder of 1. Reverse currently has a value of 0, so reverse times 10 equals 0. 0 plus our digit sums up to 1. Copy divided by 10 gives us 12.1, and 12.1 passed to the math floor method leaves us with a copy of 12. Copy is greater than 0, so our while loop iterates. 12 modulo 10 gives us a digit value of 2. Reverse times 10 plus 2 equals 12. Copy divided by 10 is 1.2, and 1.2 passed to the math floor method leaves us with a copy of 1. Copy is still greater than 0, so our while loop iterates again. 1 modulo 10 equals 1. Reverse times 10 plus digit equals 121. Copy divided by 10 is 0.1, and 0.1 passed to the math floor method gives us 0. 0 is not greater than 0, so we exit the while loop and evaluate if reversed equals our original input, which in this case it does, so it returns true. Let's translate this to code. Okay, first we'll set up our base case. We'll check if our input is a negative number. If it is, we'll return false. Then we'll initialize a let variable called reversed with a value of 0. Then we'll initialize a let variable called copy with the value of our input. We'll set up our while loop that'll run while copy is greater than 0. The first thing we'll do inside of our while loop is extract the last digit of our input by taking copy modulo 10 and assigning it to a const called digit. Then we'll update our reversed value with reversed multiplied by 10 plus our digit. Finally, we'll remove the last digit from our copy by passing the copy divided by 10 to the math floor method. Once copy is no longer greater than 0 and we exit the while loop, we'll return reversed equals our input, and this will compare our reverse digit with our input. Now let's save this and run it against our test cases. And we get the expected output. Let's copy and paste this into Leetcode. Hit submit. And we get an accepted solution.